When dealing with a residential tub that has plastic piping, traditional grounding methods using hot and cold water pipes are no longer applicable. Instead, a dedicated grounding system must be installed to ensure safety and compliance with electrical codes. The primary component of the system is a grounding rod. Firstly, you must drive an 8-foot, that is 2.4-meter, copper or galvanized grounding rod into the earth. It should be positioned as close as reasonably possible to the tub's location. This grounding rod will serve as the main grounding point for the tub. Secondly, connect the grounding rod to the grounding lug on the tub. Use a number 8 solid ground wire for this connection. It is preferable to bury this wire underground to protect it from physical damage and environmental factors. Ensure the connection is secure and made using approved connectors suitable for direct burial. Thirdly, bond the tub to the grounding rod. Connect an additional number 8 solid ground wire from the tub's metal frame to the grounding rod. This wire provides a direct path to ground for any stray current that may be present in the tub's frame. This wire can be run inside the wall or through an access panel, depending on the tub's construction and accessibility. Secure the connections at both ends using appropriate connectors. Fourthly, connect the motor ground to the tub's frame. If the tub's motor has a dedicated grounding terminal, connect a number 12 solid ground wire from this terminal to the metal frame of the tub. This ensures that the motor is properly grounded and that any fault current from the motor will be safely directed to ground. Again, use approved connectors for a secure and reliable connection. All wire connections must be made using approved connectors and methods to ensure electrical safety and prevent corrosion. It is critical to test the grounding system to verify proper continuity and resistance to ground. Use a multimeter to measure the resistance between the tub's frame and the grounding rod. The resistance should be as low as possible, ideally less than 25 ohms, to ensure effective grounding. Check all connections to ensure they are tight and secure. Furthermore, consider the following detailed aspects of each step to ensure a robust and code-compliant grounding system. When selecting a grounding rod, it is important to choose one that is approved for direct burial and is suitable for the soil conditions in the area. Copper grounding rods are generally preferred for their excellent conductivity and resistance to corrosion. Galvanized steel grounding rods are also acceptable, but they may not last as long in certain soil types. Ensure that the grounding rod is driven deep enough into the earth to reach a point where the soil is consistently moist. This is critical for ensuring a good electrical connection to the earth. The 8-foot, that is 2.4-meter, length requirement is based on the National Electrical Code, NEC, and is designed to ensure that the grounding rod is in contact with a sufficient amount of earth to provide an effective ground. When connecting the ground wires to the grounding rod, use approved grounding clamps that are specifically designed for this purpose. These clamps should be made of a material that is compatible with the grounding rod and the ground wire to prevent corrosion. Ensure that the clamps are tightened securely to provide a good electrical connection. When burying the ground wire, it is important to protect it from physical damage. The wire should be buried at a sufficient depth to prevent it from being accidentally cut or damaged by digging. It is also a good idea to run the wire through a conduit or other protective sleeve, especially in areas where it is exposed to physical stress. When bonding the tub to the grounding rod, use a continuous length of ground wire without any splices. Splices can introduce resistance into the grounding path and reduce its effectiveness. If it is necessary to make a splice, use an approved splicing method that is designed to provide a low resistance connection. When connecting the motor ground to the tub's frame, ensure that the connection is made to a clean, unpainted surface. Paint can act as an insulator and prevent a good electrical connection. If necessary, scrape away the paint to expose the bare metal before making the connection. When testing the grounding system, use a ground resistance meter to measure the resistance between the tub's frame and the grounding rod. This meter will provide a more accurate reading than a standard multimeter. The NEC requires that the resistance to ground be less than 25 ohms. If the resistance is higher than this, additional grounding measures may be required, such as installing additional grounding rods or improving the soil conductivity. It is also important to periodically inspect the grounding system to ensure that it is still in good condition. Check the grounding rod for corrosion and replace it if necessary. Check the ground wires for damage and replace them if necessary. Check the connections to ensure that they are still tight and secure. In addition to the above steps, it is also important to ensure that the electrical circuit that supplies power to the tub is protected by a ground fault circuit interrupter, GFCI. A GFCI is a safety device that is designed to detect ground faults and quickly interrupt the flow of electricity, preventing electric shock. The NEC requires that all electrical outlets in bathrooms and near water sources be protected by GFCIs. Furthermore, always consult with a qualified electrician for the installation and testing of the grounding system. Grounding systems are safety critical and require expert knowledge and specialized equipment. An electrician can ensure that the grounding system is installed correctly and that it meets all applicable electrical codes. An electrician can also perform a thorough inspection of the electrical system to identify any other potential safety hazards. Here's a more detailed explanation of each of these points. Firstly, regarding the grounding rod installation, consider the following. Firstly, grounding rod material. Copper rods are excellent conductors and resist corrosion well. Galvanized steel is a more economical option, but may corrode over time, especially in acidic soils. Stainless steel rods offer superior corrosion resistance, but are more expensive. Secondly, grounding rod size. The NEC specifies a minimum diameter for grounding rods, typically 1/2 inch or 5/8 inch, depending on the material. Larger diameter rods provide a greater surface area for contact with the soil, improving grounding effectiveness. Thirdly, grounding rod location. Choose a location that is easily accessible for inspection and maintenance. Avoid areas where the rod could be damaged by vehicles or equipment. Ensure the location does not interfere with underground utilities. Fourthly, driving the rod. Use a grounding rod driver to install the rod. This tool protects the rod from damage during installation and ensures it is driven straight into the ground. If the soil is rocky or hard, you may need to pre-drill a pilot hole. Fifthly, depth of the rod. Drive the rod vertically into the ground until only a few inches remain above the surface. If you encounter bedrock or an obstruction, you can bury the rod horizontally at a depth of at least 30 inches. Secondly, when it comes to connecting the grounding rod to the grounding lug, consider these points. Firstly, wire size and type. Use number 8 solid copper wire for the connection. Ensure the wire is rated for direct burial, typically with a wet location, W, insulation rating. Secondly, grounding clamps. Use bronze or copper grounding clamps that are compatible with both the grounding rod and the ground wire. Ensure the clamp is listed for direct burial use. Thirdly, connection method. Clean the grounding rod and wire to remove any corrosion or dirt. Securely tighten the grounding clamp onto the rod and wire, ensuring a tight electrical connection. Apply an antioxidant compound to the connection to prevent corrosion. Fourthly, burial depth. Bury the wire at least 18 inches deep to protect it from physical damage. Consider running the wire through a conduit for added protection. Fifthly, inspection. Periodically inspect the connection for corrosion or damage. Tighten the clamp as needed. Replace the clamp if it shows signs of corrosion. Thirdly, when bonding the tub to the grounding rod, consider these points. Firstly, wire routing. Run the wire in a neat and direct path from the tub frame to the grounding rod. Avoid sharp bends or kinks in the wire. Secure the wire to the wall or other surfaces using appropriate fasteners. Secondly, connection points. Connect the wire to a metal part of the tub frame that is electrically continuous with the rest of the frame. Ensure the connection point is free from paint or corrosion. Thirdly, connection hardware. Use grounding lugs or screws that are specifically designed for grounding connections. Ensure the hardware is made of a corrosion-resistant material. Fourthly, protection. Protect the wire from physical damage by running it through a conduit or other protective sleeve. Avoid running the wire in areas where it could be easily damaged. Fifthly, identification. Label the wire as a grounding conductor to prevent accidental disconnection. Fourthly, for connecting the motor ground to the tub's frame. Firstly, motor grounding terminal. Locate the grounding terminal on the motor. This terminal is typically identified by a green screw or a grounding symbol. Secondly, wire size and type. Use number 12 solid copper wire for the connection. Ensure the wire is rated for the voltage and current requirements of the motor. Thirdly, connection method. Connect one end of the wire to the motor grounding terminal and the other end to the tub frame. Use grounding lugs or screws to make the connections. Fourthly, strain relief. Provide strain relief for the wire to prevent it from being pulled or damaged. This can be accomplished by using a cable clamp or other strain relief device. Fifthly, testing. Test the connection to ensure that it is electrically continuous. Use a multimeter to measure the resistance between the motor grounding terminal and the tub frame. The resistance should be very low, ideally less than 1 ohm. Additional considerations are as follows. Firstly, GFCI protection. Install a GFCI receptacle for the tub's electrical supply. This will protect against electric shock in the event of a ground fault. Secondly, bonding of metal parts. Bond all metal parts of the tub, including the drain and overflow, to the grounding system. This will ensure that all metal parts are at the same electrical potential, reducing the risk of electric shock. Thirdly, local codes. Consult with your local electrical inspector to ensure that your grounding system meets all applicable codes and regulations. Fourthly, professional installation. If you are not comfortable working with electricity, hire a qualified electrician to install the grounding system. Electricity can be dangerous, and it is important to ensure that the work is done safely and correctly. Fifthly, documentation. Keep a record of the grounding system installation, including the location of the grounding rod and the wire routing. This will be helpful for future maintenance and inspections. Sixthly, maintenance. Periodically inspect the grounding system to ensure that it is still in good condition. Check the grounding rod for corrosion and the wires for damage. Tighten any loose connections. Seventhly, upgrades. As electrical codes and technology evolve, consider upgrading your grounding system to ensure it meets the latest standards. Eighthly, surge protection. Consider installing a surge protector to protect the tub's motor and other electrical components from voltage surges. Ninthly, wet location considerations. Ensure all electrical components and connections are rated for wet locations to prevent corrosion and electrical hazards. Tenthly, emergency shutoff. Install an easily accessible emergency shutoff switch near the tub to quickly disconnect power in case of an emergency. Remember, safety is paramount when working with electricity. Always energize circuits before working on them, and consult with a qualified electrician if you have any questions or concerns.